Yeah. Hello, good morning. We are from Group 5, want to present about trigonometry in architecture. My name is Mama Haziq Aiman Rosnan from DKM 1C. My metric number is 20 DKM 31F 1013.
Right. My name is Adam Akasha Muhammad bin Sufyan from DKM 1C. Number metric is 20 DKM 21F 1052.
Okay, my name is Muhammad Hanif Mijainal from DKM1C and my metric number is 20 DKM 21 F1088.
Yeah. My name is Aibab Abdullah bin Azani. My number metric is 20 DKM 21F10737.
Let me discuss about introduction. Trigonometry is what helps architects to calculate surface, ground surface like angles, structure, loads, and height and width of structure to design a mathematical graph that a constructor can use for construction purpose. It's likely they have plenty of available notebooks as well as software to do this. Second, trigonometry functions are what helps in drawing angles, calculating proportions, measurements, and determining the height of structure. With the help of various trigonometric functions, an architect elucidates a designer's plan that can be easily understood and used by the constructor. Let me talk about trigonometry. Trigonometry is the branch of mathematics which deal with the measurement of sides and angle triangle and their relationship with each other. Adam will discuss about trigonometry formula.
Alright, thank you, Hazik. So now I'm going to talk about trigonometry formula. Basically, this formula commonly used by the engineers. First of all, this formula will divide with three terms, which is soh, chah, and toa. Soh means sine equal opposite over hypotenuse, while chah means cosine equal adjacent over hypotenuse, and toa means tangent equal opposite over adjacent. However, not only the soh, chah, toa formula, but we have another formula in trigonometry, and this formula will divide with three terms, same with the soh, chah, and toa. The formula is cosecant, secant, and cotangent. Cosecant means theta equal 1 over sin theta equal hypotenuse over opposite. And second is theta equal 1 over cos theta equal hypotenuse over adjacent. And the last one is cotangent cotangent theta equal 1 over tan theta equal adjacent over opposite. The last one formula is Pythagoras theorem. It is a square plus b square equals c square. A equal square root c square minus b square, and b equal square root c square minus a square, and the last one is c equal square root a square plus b square. So that's all for me. Next, Aima will continue about the mathematical solution and apply the trigonometry formula on the bridge. Right? Thank you.
Now I will talk about how to use formula trigonometry on the bridge.
For example, if you stand in the middle of Golden Bridge and aim a telescope toward the top of the tower, the telescope will be angled at 13.4 degrees above the horizontal. The height of each tower above the roadway is 152 meters. First of all, we will draw a right angle triangle on the diagram below and use the information above to estimate the length of the cable running from the center of the bridge to the top of the tower. Is your answer likely to be an underestimate or overestimate? Find the x. We will use formula sin theta equal opposite over hypotenuse. Since 134 degree equal 152 over x, we will move x to the left side and it will become 0.2317 x equal 152. Secondly, 0.2317 will be moved to the right side and it will become x equal 152 over 0.2317. Then we will solve it and we will get the answer for the x. The answer is x equal 656. This will be underestimated since the cable does not follow a straight path but a parabolic curve, so it will be longer. In reality, length is roughly 750 meter. And then we will calculate the distance between the two towers. To find the answer, we have to use theorem Pythagoras formula. Method 1 is d equals square root 652 square minus 152 square. And we will get the answer for the d. The answer is 638 meter. For method 2 is we will use trigonometry tan theta equal opposite over adjacent. So tan 13.4 degree equal 152 over x. The answer for tan 13.4 degree equal 152 over x is 0.2382 equal 152 over x. We will move x to the right side and 0.2382 to the left side, and it will become x equal 100 over 0.2382. And the answer for x equal 100 over 0.2382 is 638 meter. For the last total distance, 638 multiplied 2 is 1276 meter. That's all for me. Thank you.
Okay, this is a picture of architecture.
Okay, thank you, Aima, for the explanation. And now I will talk about the conclusion. As you know, we realize that trigonometry can be used in many areas, such as astronomy and architecture. They can aid in calculating many things. They can also be used in car decks and benches. Without really climbing a tree, you can find the height easily with trigonometry. They also can use widely used in real life application and is very useful for most architects and astronomers. Then we can conclude that without trigonometry, life would be much more difficult. We are going through the troubles. You can easily find something, so we think that was a good invention by Archimedes, and thanks to this many architects need not go through the trouble to calculate things. So it really help in real life application and not only for test and exam. That's that for me.
Okay, thank you. Any question for this discussion?
All right, sorry, I have the question. What is trigonometry?
I will answer it. Okay. Trigonometry is the study of how the side and angle of the triangle are related to each other.
What? That's all?
Yes, that's all. It's all about triangle and you cannot get much simple than that.
You mean by trigonometry isn't some big ugly monster that makes students turn green, scream, and die?
No, it's just a triangle. Just that.
All right, thank you, I guess. I have another question. Why do builder uses trigonometry?
Okay, I will answer it. The foundation of a building relies heavily on trigonometry to ensure the foundation is level and stable. The contractor also uses trigonometry to determine the angles and volumes needed to cut and fill areas on the ground in order to make it level. Okay, that's all.
And also, what type of trigonometry do architects use?
For example, architect can use the tangent function to compute a building's height or if they know the distance from the structure and the angle between the eyes and the building's top. Clinometers can help you measure those angles. Okay, that's all.
All right. Um, uh, how is trigonometry were used in architecture?
Right. Thank you for the question. Uh, how is trigonometry used in architecture? Is architects use trigonometry to calculate structural load, roof slopes, structural load, ground surface, and many other aspects, including sun shading and light angles. So that's all for me lah.
All right, my last question is, why is trigonometry used in architecture?
So for that question, I will answer it. Trigonometry is used in architecture to ensure that buildings are built safely. For example, architecture have to calculate exact angle of intersection for components of their structure to ensure stability and safety. That's all.
All right, thank you. I think that's all for the question. All right.
Okay, that's all for discussion for trigonometry in architecture. We are from group 5. My name is Muhammad Haziq Aman Rosnan.
And thank you. That's all for me. I am Adam.
And I am Muhammad Hanif bin Jainal.
And I am Aimo Afizullah bin Azarni.
Okay, that's all. Thank you.